Hello, how do we find the value of k? Solution. Let's get down the question first. K times k minus k times k times k is equal to 80. K times k is simply k square minus k times k times k is simply k to the power of 3 equal to 80. This implies that k square minus k cube. If we move 80 to the left hand side, we have minus 80 equal to 0. This means that k square minus k to the power of 3 minus 80 could be written as 16 plus 64 equal to 0. So we have k square minus k cube minus this particular 16 could be written as 4 square plus we can also write 64 as 4 to the power of 3 equal to 0. This implies that k square minus k to the power of 3 minus times 4 square, that is minus 4 square, minus times 4 cube, that is minus 4 cube, equal to 0. Let's rearrange this equation. Doing that, we have k square minus 4 square minus k cube minus 4 cube equal to 0. It is very possible I can put these two guys in brackets. So I have k square minus 4 square, close the bracket. I can also factor out minus from these two guys. So that will be minus into k cube plus 4 cube equal to 0. At this stage, let's recall some algebraic properties. The first one is a square minus b square is equal to a plus b times a minus b. The second property is sum of two cubes. A cube plus b cube is equal to a plus b times a square minus ab plus b square. Take note of these two properties. Very important. Applying this first identity to this guy, you will notice that our a is just k, b is 4. So we have k plus 4 times k minus 4 minus applying this second identity to this guy, you will notice that our a is just k and b is 4. So that gives k plus 4 into k square minus 4k plus b. What is b? B is 4. So 4 square, we have 16 equal to 0. Let's continue. You will observe that k plus 4 is common. I can factor it out. So I have k plus 4 into k minus 4 minus this k square minus 4k plus 16 equal to 0. K plus 4, let's drop the square brackets, times k minus 4 minus times k square, that is minus k square, minus times minus 4k, that is plus 4k, minus times 16, that is negative 16, equal to 0. Let's proceed further. So we have k plus 4 times minus k square, k plus 4k, that is plus 5k, minus 4 minus 16, that is minus 20, equal to 0. This implies that k plus 4 is equal to 0, or minus k square plus 5k minus 20 is equal to 0. From this line, it is very obvious that k is equals to minus 4. This is the first solution. Now, let's multiply both sides by minus 1. Multiply by minus 1. So that gives minus times minus k square, that is k square, minus times 5k, we have minus 5k, minus times minus 20, that is plus 20, equal to minus times 0, 0. We can actually solve this equation, quadratic equation, using quadratic formula, which says k is equal to minus b plus or minus the square root of b square minus 4ac, all divided by 2a. From this equation, a is equals to 1, b is negative 5, c is equals to 20. This implies that k is equal to minus, what is b? B is minus 5 plus or minus square root of b square, that will be minus 5 all squared, minus 4 into a is 1, into c is 20. Everything divided by 2. What is a? A is simply 1. We have 1. This means that k is equal to minus times minus 5, that is 5, plus or minus square root of minus 5 all square is 25, minus 4 times 1 times 20, that is 80, divided by 2 times 1, that is 2. This implies that k is equal to 5 plus or minus square root of 25 minus 80, that is minus 55, divided by 2. So we have k equal to 5 plus or minus square root of minus 55 could be written as square root of 55 times square root of negative 1 divided by 2. K is equal to 5 plus or minus square root of 55. But we know that from the complex number, square root of minus 1 is equals to I. So that means we have to write I in place of this. We have I divided by 2. This implies that k is either equal to 5 plus square root of 55 times I divided by 2, or k is equal to 5 minus square root of 55 I, all divided by 2. This is the second solution, while this is the third solution for this algebra problem. That's it. Thanks for watching.